Tonight for the beginner's talk, we're going to be looking at Python type hinting or type annotations, as you'll kind of hear it interchangeably called. Try to provide some clarity around that tonight. This is a feature that first landed around 3.5. It began to get popular with 3.6 and 3.7 code bases, so you'll probably see it more and more. Interestingly enough, the basis for the type annotation syntax goes all the way back to 2006 with PEP like 3107, which was actually function annotations. So it's not like a idea that just suddenly manifested and got bolted on in the last 2 or 3 years. So what are type hints? They're exactly what they sound like. They are annotations associated with names and objects to hint at what the type of the object is, both for the reader and for analyzers. What it isn't right now and for the future is an annotation for the Python interpreter. So as we look at this, that distinction means you're going to have a tool that you're using so that when you add type hints to your code, and just to be clear, something like the scalar :float, that's a type hint. We'll look at these more, but the general type hint syntax is a name, and we'll mention that one more, but a name, and a type. That type may be one that's just built into the language, it may be one you define. And so you'll use an analyzer, or your IDE may analyze for you to provide extra feedback about your application. So one of the things that draws some people to Python is the fact that it's dynamic. I don't have to worry about types. I'm not sitting there and indicating a type everywhere I'm declaring a variable. So why would you want to take a feature that isn't there by default and add it if I have avoided other languages for that reason? So Python has been used for a variety of applications over time, some small, some large. Historically, within some communities like Linux, you would hear it called a scripting language and such. But the reality is the applications that are using Python to be built today are growing constantly in scale, and the teams are growing large as well. So Instagram, for instance, is a very heavy user of Python. Microsoft's Azure tools make use of Python. There's just these really large code bases that, at the end of the day, have lots of people interacting with them that need to understand the code without running every single line of it and inspecting that. So type hints help increase the readability and the information that you can glean from the code. It can help catch common bugs, and then because you're actually declaring the types ahead of time, static analysis tools can reason about your code better than if they were trying to guess every single name and object type throughout your application. One note is Python is dynamic, but it's still strongly typed language. So objects have types. The interpreter, and when I say interpreter, when you run your Python code, Python and whatever your entry point is, you're launching a Python interpreter. The machine does not understand Python code as you wrote it. Instead, that interpreter takes a compiled bytecode and executes instructions on the machine for you. The reason all of this is important is when you hear about dynamic languages or static languages and strongly typed, weakly typed, Python objects have a type. When you say A equals 1, A is a name pointing to an object, and that object is of type int. So I highly encourage you, if you find this interesting by the end of it, to check out the Python typing module and all the associated PEPs, and we'll look at these at the end, because what I just said gets into some really fun and interesting stuff related to type theory, What's the difference between a name and a variable, if an object has a type or a variable has a type, and things like that. And it's pretty interesting to see how different languages work and then understand better how Python and the Python interpreter work from that. So from that list, the first thing I want to look at is adding information to your program to help other people understand what's going on. And so right here, this is a hypothetical but fairly realistic function that connects to a database, and you're providing it a set of IDs. You are then going to loop over those, get a record, and do something with them. The thing about that is, if you look at it, we're doing async for IDs in ID, or ID in IDs. And then notice in our query, we have an ID. We also have a patient ID, and we're doing a where clause where we're passing in this ID from this for loop. There's a lot of ambiguity there. Are the types right? Are the types going to match up? You have to take this query, go run it somewhere, see what data type these columns are, and then you also need to understand what IDs is. So you're going to look at some function somewhere to see how IDs is being generated. And now, what is IDs a list of? Is it a list of strings, a list of ints, a list of you don't know? And then finally, when we get a row back, we're going to iterate over it. But you don't necessarily know what that row actually looks like, how it's represented, unless you know everything about this query ahead of time, which oftentimes ends up being the case when you're doing operations like this. That's unfortunate. I think. One second. Switch computers here, so. Question is, did I check in the final thing? I did, so we'll go from here for a second. So, without annotations, this is what we have. With annotations, we can actually begin to provide more information. So we can do things like typing out a dict type. And so we have a class here, we're going to call it patient record. And for every member of that class, we're indicating the types. Why is that important? Because now we've got the same function below, but notice my ID has a type. It's type int. Well, if I look back at patient record, I notice that ID is a string, but patient ID is an int. So depending on how things are named, depending on where names align or don't align, you can leave ambiguity in your code that somebody's having to guess about or reason about if you don't have any type of type information. But here, we can assume that whatever generated IDs that we passed into this function is most likely actually referring to patient ID, but within their realm, there was just one set of IDs, so they didn't specify what kind of ID. They didn't name it that specifically. But because the types align, we can be fairly confident that we're working with the right thing. The other option, or another benefit here, is when we get a row back from our query, well, our query is going to get rows, but when we begin to iterate over those rows, we can also provide a type hint here. We can say, hey, this row, we're going to annotate it with the type of patient record. Well, we know what patient record is. And we know if we go to interact with events, that we're going to have a list, and we're going to need to iterate over that or do some type of operation that's specific to a list. Similarly, we know that date of birth is a date time. And so instead of doing casting or guessing about what operations we might be able to do, we know that that's going to be a date time already. And so by indicating the types that we're interacting with, we actually make it easier for ourselves and other developers that may interact with the project to reason about our application and what it's doing. So just a couple things to highlight. This is kind of your standard type annotation syntax. So we have a name and we assign it a type. Similarly, functions, you can type the arguments of functions or you might not type them. That's the thing, is types are optional. So what you type can be analyzed, and we'll look at how you analyze that with MyPy and other tools. But for whatever isn't typed, static analyzers will try to figure that out. But if they can't, it doesn't throw an error. It's not anything that's going to be an issue. So you can go through and add types to part of your code, begin to add this to your process over time. You don't have to boil the ocean and type your entire application all at once, or parts that are very straightforward. You don't necessarily have to worry about that, but it does provide the extra readability. One place where I will call out types being kind of difficult today is anytime you're in a for loop, you actually have to annotate ahead of time, so you can't annotate a type inside of the loop, inside the actual for loop syntax. All right, so I want to look at some code next, look at cleaning up code with types. So one of the things that begins to get interesting is when you have collections. So inevitably, we've all ran into a list with dictionaries, and that dictionary has complex types as values, and typically somebody's done something really clever with JSON, or we're representing some very complex document from the real world, and the types start to get out of hand. And so, luckily, related to that, we can do things like this, where we can declare a name for those types. And so what I've got here is a function where I just want to find the index of a given meetup in a list of meetups. And so this is kind of just a mock object that I've created. And we have a list, and that list contains tuples. Those tuples have a string, and the value of that string is a dictionary. Within that dictionary, we then have keys that are yep.
Can you make this any bigger?
I can try.
Or is this something that is a goal for IC?
Yeah, it's on GitHub. Let's see if we can.
If you go to the DerbyPy, that's
better.
Profile. It's one of the first. He just added the repo, not one of those. So I guess it's at the top.
Yeah. Is that easier? Okay. So if I don't declare something ahead of time, suddenly I can have arguments that look something like this to represent complex types. Not very readable, kind of ugly, and a little confusing. Instead, what we can do is declare things ahead of time, and then you'll see that we can use that within our types. And so you can declare type aliases, or you can actually declare entirely new types. And so you can look at that in the typing module docs, where you want to use an alias versus using a new type. The other thing that's interesting here is, can anybody figure out, and I found this interesting at least, what the bug is ahead of time here? Now, it's not a syntax issue because this runs, but we get MeetUp not found. We're searching for DerbyPy. And DerbyPy is very clearly here. So I did this to myself while working on this, and I thought it was pretty interesting. So this is a refactored version of this, and so you can see instead of that crazy long type annotation, instead we just say, hey, this is a list of meetups, and this is what a meetup is. So that represents these objects here. You also notice that our function has a return type now. And this return type is an optional int. So if you've used some languages, some have added things like this, so C# and Java have added optionals. Languages like Rust and Swift and others have had it by default from day one and make you handle these. So an optional means I will return whatever type or none. And so in this case, I'm going to return an int because it's a list index, or none. The other part, so what went wrong was we returned an int. What's 0 on an if statement? False. Python is going to treat an int value of 0 as false. It's going to treat that as a Boolean false. Well, we're not returning a Boolean, we're returning an int, and collections can definitely have an index of 0. And so that was basically the issue from before, is I was returning an int, and it happened to be the 0 index, and my if statement just carried on because we can, and we'll equate to 0 to false. The other part, when I went to fix this, it gets interesting, is MyPy. So earlier I mentioned you can add these type hints, but by default, the Python interpreter is not telling us this information. It doesn't care about any of those type hints. You have to use what's called a static analyzer, and what that does is it goes through your code and just takes it as is. It doesn't run it, and checks for bugs and issues and will tell you, hey, you might want to look into this. And so MyPy is probably the most popular one right now. We'll look at a few of them. But notice when I went to fix this, I just said, oh, well, let's check if it's greater than 0 and move on. But up here I'm saying, hey, it's optional, because I might provide a MeetUp that's not in the list. And in that case, it's going to be a return type of none. And so MyPy is actually like, hey, when you go to order these, because of how the conditional is going to check and the fact that one of these could be a none, you could do this either way, but the safer way of doing this is going to be checking for is not none first, and then checking that it's greater than or equal to 0. And then with that change, we get the right value. We get the index of 0 shown. So, small bugs, easy bugs. It's an if statement. It's got a value. Why would we not show it? Well, because 0 is false. So little things can trip up your application pretty quick. So that's, looking at it before. We don't know the return type of this function. We've got a pretty nasty thing here, but it is actually telling us what we can expect. Like if meetups wasn't a defined object in my application, let's assume we're making a request against a REST API and getting something back. Instead of somebody having to guess at the structure of that or run your application, put in debug points or things like that, you can actually just provide them the information that, hey, this list is going to contain objects with this structure. And they know that, and they can keep going. So, that's some type hints. Type hints are also really useful for catching common bugs. This is an anti-pattern that I have grown to hate within the last year probably, and I don't know what quite kicked this off, but everybody is using get on dictionary keys now, and it drives me nuts because people think that their code is safer because they're using get and it's an accessor and it's not going to fail not finding the key and different reasons. So just if you're not familiar, when you interact with a dictionary and you search for a key, you can call the get function and provide it a key name, which that DSN should be in string quotes. But and if it doesn't find it, then it will return a default value. But by default, it returns none. So you can end up with fun things like unhandled optional values. So let's say we check our environment for DSN. And it's not found. Can anybody tell me from this error what actually happened? Now take this and go 2 functions over and 10 lines deep in a traceback somewhere in an application that's new to you, and you're dealing with a none type issue. When if we had done this, it would be very easy to know that that key doesn't exist in your environment. But instead, because we're writing code that feels safer to us at the beginning, we get an obscure error that we have to guess about. And eventually you'll figure it out, but you're not dealing with the optional. Okay? Similar. we've got a dictionary. We want to look for something in the dictionary, so again, we call get. Well, now we've called this, and again, we get this weird none type. Well, what's none type in get? Like, why am I getting that? It's because we're not dealing with optional values. And so instead, we need to be doing things like if MeetUp. And so you need to have these safeguards and checks here. And so by providing types, providing the right information about your application, looking at where things are optional versus where they're concrete, you can begin to stop bugs ahead of time. You can also make sure that your application is written in a way where your defensive coding didn't become obfuscation and make it harder for the next person down the road. And then finally, type hints can also help you find incompatible types. So let's say that we wanted to get a row of data and append a date to it because we're passing it on to somebody else and they want a timestamp on it to know when we were interacting with it. Well, we create our function, we're going to take a row, we're going to get the date, we're going to append it. So for many of you, if you've used the Python for a while for database operations, it's pretty common for database rows to come back as tuples. But a lot of people are used to working with lists and might make assumptions, and so they may try appending data. There's nothing here to kind of indicate what's going wrong. You don't know that there's a tuple in here anywhere. You don't know that there's a list or not a list, and so you're kind of left to figure out what went wrong on your own. So in here, we begin to indicate, hey, this row needs to be a list. When you call this function, I'm expecting a list. And so at that point, you can look and say, oh, well, I'm getting back a tuple from the database, not a list. And begin to handle that by using type coercion, taking our tuple, transforming it into a list, and providing it to the function in the right type. All right, so those are just some ways type hints can provide additional context to you as a developer. It's not going to be uncommon for you to look at code that's well over 6 months, 6 years, 10 years old from time to time. And with no context, you get to figure out how to run it without breaking things, which is always fun. And then put in a debugger on there to see what's happening. Begin putting print statements everywhere. And instead, by providing some type information ahead of time, you can save yourself and others a lot of pain when they go to read your application later. Additionally, you can use it to catch some bugs, to provide additional context to the analyzer so that it can provide suggestions to you as well. And then finally, one of the potential uses for Python type annotations is performance. So PEP 484, the PEP that is the abstract for type hints, clearly says that Python will remain dynamic and that the interpreter will not require them by default. But other projects, other interpreters are welcome to do differently. So Cython is a project that takes Python, transforms it into compiled C code, can make use of type hint information to make that transformation and translation better. MyPyC is a project that's coming out to take type hinted code and turn it into C extensions for Python. And so it's not completely out of the realm when you have projects like PyPy, and there's a Rust project recently to rewrite the Python interpreter in Rust. It's not out of the question for there to be an interpreter that's actually a high-performance interpreter in the future that requires use of type hints to get that type of extra performance. So some extra docs to look into if this seems interesting or if you're just curious about it is in the standard library, the typing module lays out a lot of this and goes even further in depth. It shows all the types that are part of the standard library by default. PEP 484 is the abstract for type hints and kind of talks about why and how these are being implemented. And then type hints continue to get new functions and functionality. So Python 3.8 introduces a protocol syntax. So everything we looked at before were concrete types, which when you're trying to write generic functions can get kind of difficult. Protocols basically let you say, the object has to have this type of behavior, but you're not saying what kind of object it is. And Python 3.8 also adds the structured dict as a standard type, which lets you specify types on a per key and per value basis. Some additional reading. Vicky Boykes, I know I just butchered that, but she wrote a really interesting article on this, so definitely check that out. Real Python has a good article on this. And then 2 books have come out recently. The first one's from Manning, the second one's from O'Reilly. These books are both written with Python, specifically Python 3.7, and all of the examples contain type annotations. So if you want to look at example code, kind of see how this is being used, those are a couple of recent books that use that. And then I kind of mentioned throughout this that you have to use a static analyzer to actually glean information from these types. So in the repo, you'll find a little IPython magic, which is what I was using in the Jupyter cells to get that feedback. That's using MyPy. MyPy is, I would say, arguably the most popular static analyzer right now. It is a pip install. It is cross-platform, so Windows, Mac, and Linux. And it's also kind of the reference implementation of static analyzers relating to the PEPs today. PyAnnotate is an analyzer you can actually run as part of your application if you want to, and it will generate types from your application's runtime. So if you have existing code that you want to get type information for without going through and guessing, or you just going in blindly, you can actually run your application with PyAnnotate. It's going to slow it down a little bit, but not a whole lot. And at the end of the application's run, it will actually generate a stub file of types for you that you can then go back and add to your code. 3 other analyzers, just real quickly. PyType is from Google. It's probably the next friendliest after MyPy. Pyre is from Facebook. It has external dependencies such as OCaml, as well as being platform specific to Mac and Linux. Pyrite is from Microsoft. It is actually a fully separate application with external dependencies, and it's an NPM install, although it does support all platforms currently. So that's a rough overview on Python type hints, a bit of the syntax, why you might want to use it, and the tools that you can use to implement it tomorrow when you go back to work.
Alex?
Yep.
So they get used for static analyzers. They get used obviously if you're reading code. They throw you a bone or so on. Do they do anything actually running the code? I mean, if you violate the type, it still lets you do it, right? Okay.
Yep. So the interpreter completely ignores it.
Okay.
You said you could have your own data types being typed?
Yep.
Like array sizes and everything?
I haven't seen, so that's actually an interesting, I haven't seen anything that implements like
I always
size.
bump my head doing little toy apps on array operations.
Yeah.
And I just don't have the right, array size, and it blows up. I gotta go do shape for this, shape for that, just to understand what I did wrong.
No, I haven't seen anything that, because, I mean, a list is inherently long, depending on what you put in it, right? So unlike other languages where you might declare the size of an array before you use it, a Python list is going to be dynamic. So, yeah. Well, you don't declare the size ahead of time, it's just immutable once it's declared.
Is there something maybe in the array library?
Yeah, if you want to drop down to like the C types and C
There might
extensions,
be
you
some-
could.
Yeah, you could do it with a C type, but
Yeah.
might be something in an array library. I don't remember for sure.
Yeah, but I guess you could actually define that as a protocol in Python 3.8. It would just be really interesting, but yeah. Any other? you have questions about it, let me know. Used this extensively in a recent project, and it helped us quite a bit, especially when we were mixing it with async IO, and just kind of we had some code that was async and some that wasn't, and you don't have to guess about which kind of queue you're about to drop some objects into and make things explode. Thanks.